much time in class. Glorious. Although, class people are universal students.
Wait, why was it universal?
International students had a chance to go on a field trip, and they're like, missing school? Yes.
Harass Tyler and Jacob.
Which you guys would probably do too. And then a few extra people are gone because I don't think
Alright, I left my spiral up there. Hang on, guys.
or Maddie.
Ricky's in
Wait, are we just doing homework?
Yeah.
Dude, I know nobody likes Caleb. Right?
Yeah, I got that.
Yeah, you can go first.
Bye, Jacob.
Alright, cool kids, here we go. Homework spirals, color pens, we're taping.
Where is Ricky though?
I think you scared him away. I don't know.
He has whooping cough.
He must not be going to prom. That's kind of sad.
Oh, that does suck.
No, I think
They just show up today, otherwise. That's a struggle.
Oh, he has to show up today. Otherwise,
For a school event.
Oh, yes.
Hey, good deal. Alright, cool kids, here we go. Number 14.
I feel like making jokes about replacing it.
Alright.
Would be really good.
Kudos. There's no other option for number 14. What mode? Hey. What mode do you have to be in your calculator? It says 1.35. Which one? Radians. There's no degree mark. There's no degree mark. So, 4.4552. Number 24. M is equal to negative 7/9, hence we rest it equals a tangent. We solve using tangent inverse. You can be in radian mode or degrees. They said they didn't care. Either one was good. Number 28. With 2 points, we can find a slope. We actually, I think we modeled every single one of these types so far. We find a slope and then square root of 3 over 3, 1 square root of 3. So that would be a 60 degree, because 30, 45, 60. That'd be a 60 degree, but it's negative, so it's in the second quadrant. So we do 120 or 2 pi over 3. Number 52. All you do is, like we modeled in class again, solve for y, plug in your M1 and your M2, and watch out for those fractions. Technically, you're using your calculator anyway. So if you're using your calculator anyway, do you even technically have to simplify the fraction by hand? But I would if I were you, just to keep everything on nice and even and equal and all that jazz. Be very gentle with your mistake.
Tyler.
I would have used, what's that shortcut to get the nice little fraction you do, like already ready to go? Alpha. Alpha y equals, not second. Alpha y equals enter. You get your nice little fraction. Remember n over d, and it shows you 2 boxes. You can fill in the top, fill in the bottom. And when you tell me absolute value, you can go math and get the abs, get the absolute value. Not that kind. That'd be nice. I'll get a math button.
I would like that.
Or should they all have this?
But
But once again, degrees or radians, all good. JJ.
28.
Oh, do Monday.
Can you explain how you got -3
Oh, whenever you're simplifying radicals, ironic, we're actually doing this in Algebra 1 right now, and they're having a horrible time with it. You can think about this as negative 2x minus 1x. They're like terms that you can combine. Now, for you guys, you understand factoring a bit better than Algebra 1 kids do. They've seen it, but of course they're not masters of it. Couldn't we also see this as a binomial, and couldn't we factor out a negative root 3? And we'd have 2 plus 1.
Sure.
So that's one way of thinking about it. I actually think that's easier than thinking like terms, because you're just like putting numbers, that's weird. But factoring, you're like, oh, okay, no big deal. 2 plus 1 is 3, so negative 3 root 3. But in algebra, you also probably like combining like terms with variables. You can think of it that way. Keep the root 3 and then just combine the closest. Good question. Do we have any more evens, cool kids?
No.
What? Go team. That's not bad. Did we get stuck on any odds? No.
You're on.
Okay. Now, there were quite a few things I know going on yesterday. There were volleyball games, there was an away track meet, there was a worship night, if you came to it, that could have delayed you from getting this homework done. Except, wasn't this the one due yesterday?
No.
Depends how you look at it. It kind of was.
In the
Yeah,
words
that's
of
exactly what I'm
Frankie the
about to
Wise.
talk about. So thanks, Jason. That was a good reading.
We give it
Um,
wise.
We're all tired. Spring break is coming, but it's not here yet. We're not in 8th grade and we're not going to Washington, D.C. So it's not here yet, right?
Yeah.
So therefore, in order to encourage you guys so that you don't have like absolutely nothing done going to spring break with these high hopes of I'm going to catch up on everything and you do nothing again, just a few of you have the discipline to catch up and that's okay. Any homework due next week, there will be a spot check the day of to make sure that you've done at least 75%. Just because it's for your own good. You're not going to remember this entire chapter to do it the test day.
Can we not tell Ricky this?
So once again, it's on the video. Hopefully you'll check it. Hi, Ricky.
Hi, Ricky.
And Maddie.
Hi, Ricky.
And the people who were gone, the Yvette's gone.
And all of the foreign exchange students.
Not necessarily. Bring it back. Although I'm jealous. I don't think. So, bring it back. Once again, any homework that's due next week, there will be a spot check today at 75%. Alright, so let's go ahead and get out of this. Let's go back into our notes because speaking of homeworks that are due, it's time for 10 That kind of rhymed.
5 or 6 is just start.
75% done.
Oh,
Which means you could have gotten stuck on 1 or 2.
Which we have at 30.
Does that make sense?
Is,
You could have gotten stuck on 1 or 2.
that should be 60. No.
Alright, cool kids, here we go.
Oh, yeah.
Notes time. We're gonna finish 10-2 today, and my goal probably should be to start 10-3, but we'll see how we do.
Go back one slide.
Go back one slide.
I know, I did it yesterday. Look at how ugly my hyperbole is.
Oh, wow. That's pretty. That's not.
What?
Well, that's not what you think. It's
tomorrow.
That's pretty.
I'm planning on it. I have a
I
friend
just did that in
who
like
have
2
ours
seconds
arranged
and
exactly
I.
this way, so I'm trying to figure out what.
Don't go wrong.
This sounds like that. If I was going, I would want you there. Let's do it.
But you didn't ask.
Robert, you making a appearance?
Cheers.
Oh, that'd be cool.
Get a hot
I mean, Mr. Che might be there, and he has a
Yeah, but we all want Mr. Crawford, so.
Yes. We are being recorded as we speak.
You idiots are being recorded.
Okay, can you say maybe used against you? Okay, so, coming back. I guess I should have written you those rights earlier in the year.
I killed the biggest 20 bleach.
Kiddos, we have these new equations. Do you have them written down? If you were one of the highlighter types, hey, good job. Bravo. He was proud of that one. So, we need to talk about how to get these parabolas, how to take an equation, get a graph, take a graph, get an equation, take some random clues, and get who knows whatever they want. So, you guys ready? Keep those close. Here we go. Yesterday, right towards the end of yesterday, we had clues, and my very first thing that I said as soon as we saw our first equation with clues in the comment section chapter is graph it. So, why is my, let's see if you remember, why is my parabola facing that way? Why not up? Why not down? They didn't tell me it was a right oriented. Yeah. The parabola focuses on the focus. I like to say it eats it, kind of like a greater than or less than sign, but whatever. If you want to think about focuses on the focus, that works too. Unless you think it's an eyeball, that's kind of looking the other direction, that's a bad idea. Anyway, let's say it's a mouth. Eating the focus. So we know that it has to face right, even though they didn't tell us that. Question, does that point us to a certain type of formula to set up to try to plug into? Okay, look in your notes, right up above. Which one, with the x being squared or the y term being squared, which one would be the correct formula to use for this right-facing parabola? Oh, not the x being. Think, y equals x squared. A normal parabola faces what way? Up. Oh, not x squared.
Y squared.
X squared's up, down. So if it's right, left, I'm doing the y squared one. Now I'm gonna go ahead, just because I don't have the notes shown on the screen, I'm gonna do y minus a quantity squared equals, this is what I'm trying to plug into. Do we have anything right away we can plug in?
I think we have a P and an H. I'm not sure what they mean, but I think we have them.
What do we do with the vertex? Where does he go? Yeah, he's H and K, so we can go ahead and say, okay, well the vertex is, I don't know why I'm still with the yellow pen, sorry. The vertex is 0, 0, so I can plug in x minus 0, y minus 0, and I'm missing.
4P.
So I have the 4, that's easy. What is, bless you, the P? We didn't label it in our picture. Guys, go back real quick. In our picture from yesterday. P denotes the distance to the focus. And if you think about it, the distance from the focus to this random point on a parabola has to be congruent with the distance to the directrix, true?
Sure.
So what is this also going to be? Yep, they're both going to be P. So whether they give you a hint of a focus or a hint or a clue about the directrix, both of the distances will give you the P that you need to plug into your standard form equation. So, did they give us anything that we can plug in?
Yes.
Yeah.
Yeah, it's like 2.
They didn't tell us the distance, but we can figure it out ourselves, can't we? What's that distance? Think about the tick marks.
2.
Got it. Now wait, here's where it gets a little tricky. P is sometimes positive and sometimes negative depending on which direction it's headed to the focus.
This one's probably
Focus on the focus. Is it going positive to the focus or negative to the focus?
that way. Positive.
Yeah, because it's going to the right from the vertex, so therefore we're going to make it a positive P. Now you can always double check because when you simplify, didn't we talk about yesterday how a right-facing parabola is supposed to be positive anyway? And if you don't remember what I'm talking about, right? If A is greater than 0, doesn't that mean that A is positive? If A is less than 0, then that means negative. There is no A anymore. What is there instead now?
P.
A P. So if concave up, then my P is going to be positive in my equation. Or the P coefficient is going to be negative in the equation, right? So we can, what we used to think about as that A coefficient, now we can think about for finding our focus directrix, that P coefficient instead. Same thing down here, facing to the right, facing to the left. Okay? So the positive negative trick still works, not just for smiles and frowns, not just for ups and downs, but for right and left also. Number 21, this is technically, I don't know, there probably should have been a number attached. Number 21 says, hey, keep the exact same direction, vertex at the origin, and, but switch. Instead of having a focus at 2, 0, now what do we do if the directrix is y equals 1? Draw it. Draw it. Don't keep just thinking. That's too hard. Draw a picture. You have the vertex where if you're following the same direction.
0 and 0.
0, 0. So put a point at 0, 0. And then you just have to remember y equals 1. What kind of line is that? Y you can.
Fly.
So you go up to 1 and then you follow the tick mark, which is going to go across. You go up to 1. Follow the tick mark, which is across. You guys tell me whether this is an up, down, right, or left. Specifically up, or down, or right, or left.
Oh, down.
Down.
Down. That's
Why?
down. Because I don't know.
Okay, look at the picture. What do you know?
0, 0, 1.
Why does it have to be down? Porque, por qua, ha, ha. Why does it have to be down?
Because the director has to be.
The parabola never hits the. Jason and David, are we tracking? Hmm? Why does the parabola have to be facing down? is it allowed to ever hit the directrix? If I drew this parabola any other direction, if I chose to draw it to the right, question, wouldn't it hit? If I chose to draw it to the left, wouldn't it hit? If I chose to draw it up, oh my goodness, it's hitting all over the place. So, the only way the parabola can go is down. So what formula am I using now? I need to lock the orientation. Sorry, it's spinning all over the place. Okay. Who squared? So if x is squared, that's what we're trying to plug into. As you guys talked about for the last example, we already know our, I wrote h because I was about to say it. We already know our h and k because our vertex is at the origin. We already know our h and k because our vertex is at the origin. So I have my x minus 0. But who am I still missing yet again?
The P.
The p coefficient. So therefore, how do I find it? What do I know? Ooh.
So the P is 1 because there's only one.
Distance. Distance. Distance from the vertex to, I don't know the focus this time. But I do know the directrix, and if y equals 1 is my directrix, the distance must be 1. Now, pause. Think. Should p be positive 1 or negative 1?
Negative.
Why?
It's
Point it out. It has to be a negative. It being the coefficient for my parabola. So therefore, I can go ahead and plug in my negative 1. At this point, the name of the game is just simplify. There might be different ways of writing this, like the bottom one you could solve for y by itself. The top one you could as well by taking plus or minus square roots. But guys, that's just algebraic simplifying. Doesn't mean you can't make a mistake on it, but that's not something for us to spend tons of time on. Maybe.
So why again do you choose the x squared formula instead of the y squared formula?
Because this is an up-down, a vertically oriented problem. Yeah. So if you guys look at those formulas on the page before, make sure that you have, see how I tried to tie them together? Up and or down is always going to be, if you guys like it a little bit better, you can show both, right? Up or down depending on whether p is positive or negative. It's going to go along with the x being squared or the x term being squared. Right, left. I should have done one. Right, left. Depending on p being positive or negative again. Is the horizontally oriented, meaning horizontal axis or vertical axis. Let's see. Okay. Now, I'm about to show you a pretty packed page. Pause.
Pretty back page pause.
Pause.
Okay.
There are a lot of formulas on this page. Every single sketch shows you the different possibilities of up, down, or right, left oriented parabolas. How to find the focus, because there's only one for parabolas. How to find the focus with a formula, given a p with an h and a k in a standard form. How to find the focus, the actual point by plugging in. How to find the directrix by plugging in. Same thing for downwards facing, but this time you have a negative p, therefore everything's going to be oriented in a different direction as far as positive or negative. Same thing with right, same thing with left. Are these formulas good?
No.
Yes, for some. But they're also annoying for others because they're like, wait, if I get the visual hang of these things, maybe I don't have to memorize 3, 6, 9, 12. There's probably even more than 3. 1, 2, 3, most of 3. 12 different formulas with pictures. But some of you are like, no, I get this, and I can have this on my homework, and I can use it. It's up to you. If you guys want this real quick, take a picture, send it to the people who want it as well. Or it's going to be on the video and or on the notes online. If you want this, I'm not going to give you time to write it, but you can use it. You can try it. It's in your book.
Get out of my way.
So you got to plug and chug to like formulas, etc. Thanks, Mom. Go team. You guys still going? Okay, now that I've seen where your phones are, some of you are hiding them. Put them away so that you're not using them during class. All right, ready, set, and go. Next example. Once again, I'm going to keep showing things. Using the visual clues that I use, because I don't like memorizing tons of stuff if I don't have to. Sometimes you have to. Right? Physiology test. There's no way around that. You gotta multiply. Memorize all sorts of stuff. However, math, you don't always have to memorize everything. Go team.
Study skills.
Has anybody tried it yet?
Oh shoot, we're supposed to do that. So it's this way.
If you see the picture, you could go ahead and say, x equals measures up, and I'll show you how to use the formulas. But if you're like, I think I might be able to get the visual clues, what should you be doing right this second?
Drawing a picture.
Drawing a picture.
Just did.
You know what? Positive or negative?
Positive.
But it's not going up, careful. You still have the wrong equation.
Oh, yeah.
Yeah.
Okay.
Yeah, good. Yeah, can I show the formula just for those of you guys that aren't drawing the picture? You're like, I don't like pictures? Well, you're gonna have to see a picture. But do you guys see how the focus is always a point? That is what it is, what it is. But the directrix is only x equals when. Ready? Directrix. Let's see. Directrix. That's a y equals. Nope. That's a y equals. Nope. That's a x. Ooh, okay. So these bottom ones are x equals. So I know right now it's going to be one of these bottom scenarios, okay? Because right away it says directrix x equals -2. Now question, if the directrix is x equals -2 and the focus is +2, directrix is -2, focus is +2, is it going to be directrix on the left and focus on the right, or directrix on the right and focus on the left?
Directrix focus left and focus on the right.
Okay. So maybe even using the formulas to some extent, you still need to kind of visually grasp what's going on. Maybe it's good to graph no matter what, whether you're going to try to use the formulas or whether not. But once we do start graphing our clues, looking at the picture, you should be able to fit it into this case pretty quickly, where it already tells you, hey, the formula to use, and it already tells you some of the different things, like, hey, there's the focus, hey, there's the directrix, vertex is halfway in between. Once again, do you necessarily have to memorize this whole chart? No. Let me show you how I would have thought about it and how I saw some of you thinking about it. It's the best way, it's just a way. X equals -2 on the x-axis, right? -2 and follow the tick mark. Focus is +2, +2. If you just graph those two, can you guys figure out it's going to somehow be facing the right?
Yeah.
Because doesn't the parabola need to eat the focus and not intersect with the directrix? Yeah. My vertex was off on that. Do you know why? Where's my vertex going to be? Right in the middle, because I know that it has to be equidistant from the focus and the directrix. It has to be halfway in between. So if you draw a line from the focus straight to the directrix, the vertex is on that line, and specifically where on that line?
Middle, right there. Middle.
Yeah. P has to be the same on either side. So if I say it's 2 on that side, 2 on that side, the vertex must be in the middle, which is at 0, right? Count your tick marks. I have 2 there, 2 there, so halfway in between, distance of 4. identify that. We already know the focus is 2, 2. You know the directrix is x equals -2. What else can we label now that we've figured it out?
0, 2.
0, 2. So, kiddos, if my parabola is going to be facing, let's do gray just so it doesn't intersect with everything. Somehow like that. What equation am I going to be using? The y squared one, it's a right-left facing. It's not the normal y equals x squared up-down type one. So I have my y minus k equals 4p x minus h. Does anybody know why I keep on writing it before we start plugging in?
Memorize.
A, we can reference it, and B, hopefully it helps you in seeing it over and over and over again. So you get used to the formulas, yeah? Okay. So, y minus who? Who's k? It's our vertex, right? So, y minus 2 quantity squared equals 4 times, we'll get back to the p in a second, we're just dealing with the vertex, x minus what?
0.
If you notice, 0 is the vertex of, the x of the vertex. P, oh right, the distance to the focus, how far? 2, positive or negative? Because I'm headed to the right. True? Headed to the right, so a positive 2, and all I have to do now is simplify a little bit, yeah? Y minus 2 quantity squared equals 8x. We haven't done this a lot. I know for you guys it's probably annoying. Class feels like forever. For me it's glorious, so we can get more done. I'm like, oh, we have so much time. All week was like, ooh.
Yeah.
Calm, collected. All right. Better question. Can you even get this in your graphing calculator?
Oh, use square root and then add 2?
Why? In your graphing calculator, you have to get who alone?
The y.
Or next.
Worship.
There's an it. No shaking head on that one. That's a pass back. Okay. Caleb, you said spherical size, and the reason is in the graphing calculator, the button is called what? To graph something?
Y equals
Y equals. We have to get y alone, true?
True.
So I just want to make sure you guys could get y alone if you ever needed to get y alone, and you were allowed to use a graphing calculator. There's a lot of ifs that need to be met, but that's okay. We square root because we need to undo the square, true?
True.
When we square root a square, a couple different ways of thinking about it. Long story short, you get an absolute value. An absolute value can be a plus or minus. We have to have plus or minus square root of 8x. Basically comes back to absolute value. A lot of you guys probably didn't learn it that way, but that's the idea behind it all. So then we have y minus 2 equal plus or minus square root of x. To get y by itself, all we got to do is some algebra. Add the 2.
Oh, you put both.
And Nathan, that was my next question. How many equations are you actually going to have to put in your calculator?
Those.
2.
Those.
1 for plus, 1 for minus. Once again, there's no plus minus button in your calculator. Why am I saying that? Because so many kids are like, where's the plus minus button? I feel like you should be able to program that, right? Plus or minus means graph over positives.
Your answer means you
You want to contact Texas Insurance and be like, guys, you got it wrong. Okay. Ooh, that's an application. You guys remember yesterday how I was like, hey, there's an actual reason for focus?
Yeah.
Oh, party person.
I remember.
There was an actual reason for a focus. There's multiple reasons. However, I was like, there's probably something that you guys have never thought about being related to a parabola and its focus before that truly is dependent upon this idea.
Horse races.
What's this?
Like, you.
What's going on? What is this thing?
A torture device.
A mirror, a telescope mirror.
It's an evil death ray.
a giant radio.
It's a giant.
It's the Pixar mascot.
Is that not a radio dish?
That's the cornea.
It's the Pixar mascot. It's Mr. Lexo Jr. Is that the ball?
Is that a flashlight?
I told you it's a
It's a bomb. It's a bird. It's a plane.
It's a nuke.
No, it's not a flashlight.
What do flashlights do?
Flashlight.
Point light in one direction. What? Why is that weird?
Because
Why
one
does that
direction's
take
broken
math?
up.
Yeah. Do you think that they actually thought this through?
You need to focus the light in a beam. True? Right.
Yeah,
You can
but
focus the light in a beam, right? If you turn on the lamp, what's it do?
It lamps.
It shows light. Take off the lampshade even more, right? It emits light all around. But a flashlight, what does it do?
Flashes light.
Directs light. How does it direct light? Do
Magic.
you guys know the exact type of flashlight I was trying to very crudely draw?
No. Is there
No?
is there a name?
The ones where you like unscrew the top and then there's like the little light bulb poking out and there's like the little mirror-y do, like the really old type. Have you guys seen those before? Like the really heavy duty?
Yeah.
Okay.
There's no
Where's the little baby light bulb?
in the middle.
At the focus of the parabolic reflector.
did they actually think this through though when they were making a flashlight?
Or did they
Or were they just like
Did they
let's-
just experiment and happen to get it right eventually?
That would
yeah,
be
they
my
were
assumption.
probably just like let's make a
Research project.
shape to
Extra credit research.
Or maybe they realized they needed to focus the light by having the light at a particular spot, and so maybe that defined
Yeah, but
the
I
focus
doubt
of
that
the
they
light.
looked through the math of it first.
Wait a minute, what did I just say?
That they
Focused, but they didn't
Maybe
like
they experimented and they figured out the point, and so that's where the definition of a focus comes from. I don't know which one came first, the parabolic focus or the light bulb
my bet's the
in a
chicken.
flashlight.
I say the chicken.
Science is the experimentation, math is the application or the definition. Anyway, so coming back. Something cool as far as the practical application of a focus. There is another practical application. But first question, have you guys ever been in like one of those photo shoots? Well, I don't know, maybe not a photo shoot, but you've seen photo shoots, like you've seen them on like TV or something where you have those people with those really annoying like reflectors in order to get, even like in chapel for the all school, whatever, they're shining that thing above. Is that parabolic or flat?
I don't know.
Why is it flat? It is flat. Why? It reflects light, but if you're doing a photo shoot, what do you want with that light? You want it to help
Spread.
the entire lighting of the situation usually, right?
Sure, yeah.
So why wouldn't you have a parabolic reflector?
because that would make it
Oh, just in general.
That would
Like
give you a
as
beam.
system,
You
gotcha.
want a general liking of the
Yeah.
whole situation.
That's fine.
I don't know if you guys ever wondered why they have this big old like random flat sheet. Okay. But here's another application. It's a little bit more important as far as this class being free. What?
Calculus. Oh crap.
Okay.
tangent.
Tangent. If you guys have any friends, which most of you do, have at
Nope.
least one in
Got whine about
calculus,
it?
you can be like, hey, we talked about a tangent line today, and they'll be like,
They'll have flashbacks.
Hey. that was good.
me slacker. Okay, so, more of a pun then, whether it was intended or not.
Was it intended? Good job.
Tangent line. Guys, this one's actually important if we're actually doing this one. Like it's an actual problem homework, or two. We are going to do, with geometry and a defined focus, and not even directrix, a defined focus and a parabola, what the calculus kids do with limit definitions of derivatives. Well, and shortcut rules, to be honest. But the shortcut rules don't come until the idea is established. Because the shortcut rules don't give you a foundation, the ideas do. Let me go ahead and zoom in on the picture, but first of all, if you guys haven't gotten it yet, slope of tangents. And here's something I need you guys to underline, because sadly, we're not doing a slope of any tangent line to any function. We're just doing the slope of a tangent line to a parabola. Only parabolas, I don't even know where I was going with that. Only parabolas have a single focus. parabolae have single foci, but then that's plural and I don't want that. Only a parabola or a parabolic function has a single focus, from which we can go ahead and find a tangent line. Wait, tangent line, you guys solved tangent lines in geometry. This isn't calculus. Tangent lines to what in geometry? Circles. Tangent line skims, secant line goes through. There were all these special formulas to like memorize, etc.
Yeah.
Okay. What's different between a circle and a parabola? A lot.
Circles are circles and parabolas are parabolas.
You guys could write down the reflective property of a parabola, but in all actuality, the picture is what you need after you've written down the slope of tangent line to a parabola at a point. I'm going to give you a quick context too, very quick, because we're not doing tons of calculus today. We're actually not doing any calculus operations today, but we are answering a calculus question for one specific type of function. Slope. Back in the day, chapter 1, chapter 2, and algebra 2 and algebra 1, you have been taught, whether or not you remembered, that slope relates to rate. That slope relates to rate. If you have a graph, think like like a physics lab, not that many of you guys have done physics labs, but if you're in a physics lab, you're working out and you're trying to apply the things that you're learning in the classroom, right? Chem lab, bio lab, etc. In a physics lab, you could be asked to approximate rates and then graph what information you found. Like you're actually, trying to work out with a stopwatch and with like some sort of object that moves, like one of those cool little pullback cars and it moves on its own or something like that. You could be trying to record data of how far it's going after a certain amount of time to try to figure out some sort of deduction as to its speed or how fast it's going. If you were graphing that, time would be your x, distance would be your y. So then the change in distance over change in time. Wait, that's something important. What equals distance over time? Rate. Miles per hour, feet per second, centimeters per minute. I don't know. All of those are rates. Slope is rate. However, up until this point, we have only been able to find slope of secant lines, or lines that have 2 points. Because we talked about in the very beginning of section 10.1, what is the old school formula for a slope we've been using since, a long time? Y2 minus y1 over x2 minus x1. By definition, how many points are there? 2. You need 2 points for a line. True. Why? Well, because a line has constant slope, so any 2 points, whether it's there and there, whether it's there and there, we talked about this in 10.1, whether it's there and there, right? Whether it's there and there. All of these are going to be roughly, they're perfectly, they'd be proportional. All the ratios would be the same. Constant slope no matter where you take it. But the problem is, to other functions, the slope changes based on where you are on the function. And the slope is actually seen by the tangent lines that skim. The slope is actually seen by the tangent lines that skim. Another way of seeing it, I don't know if I can zoom in as much as I would like, but if you were to zoom in on any single point of a graph, doesn't it pretty much, if you zoom in far enough, shouldn't it look kind of like a line?
Yeah.
Now the dilemma though is, even though it looks like a line, the line truly only hits at one perfect point. Unless it randomly connects somewhere else, like of a non-parabola, if you have something like that. You might have a tangent line that hits somewhere else, but it's a random somewhere else. So I guess a tangent line could hit in one more point, but not one that we would know anything about. So how on earth are we supposed to find the slope or the rate at one time instead of the average rate over like a whole period? And how does that have practical applications in any way, shape, or form? Is it important to know what's going on at an instant and not just what's going on average over a time interval?
Probably.
Sounds kind of important.
Occasionally, yeah.
And rates can apply to business and economics and stocks, and it can apply to motion, it can apply to physics, and it can apply to energy and work and all sorts of stuff. Anything that's moving, anything that's changing. That's why calculus is called the math of change. But anyway, coming back. We have a parabola. We have this snazzy tangent line, and we have this dilemma of, if only we had another point. Except we have this really cool property that the distance from a focus to any random point is going to be congruent to the distance. Oh, really? To the tangent line? And the answer is B. So what was, in a sense, an impossible problem before without calculus instead of infinitesimals, which is highly debated because it's like they're nothing and they're becoming something. Back in its day, a long, long time ago, Isaac Newton and Wilhelm Gottfried Leibniz, I forget what his first
Did
name
anyone do the Wilhelm screen?
No, Caitlin, no.
How do we find the slope of the tangent line? Well, we say, you know what, the first thing that we need to do is find D. How do we find distance between two known points? Quick review. We got this, right? x2 minus x1 quantity squared, unless I make that an x2 for some reason. Plus y2 minus y1 squared. So first things first, we're going to find the distance. That's step 1. Step 2. Once we find the distance, we're going to say, sweet. We have to go ahead and for vertically oriented, we need to subtract that distance. In general, we'll say focus minus D. Maybe it's the y value that's subtracting if it's an up-down. Maybe it's the x value that's subtracting if it's a right-left. But we're taking away the distance from the focus to get to a new point. Step 2. So we have the point P, we have the focus, and then what are we going to call this other random point? Q.
It's called Steve.
Caleb, stop trying to
We'll call him
and
S.
interrupting class.
Okay. And then all we have to do is go ahead and say, sweet, the slope of the tangent line, m of t, we're going to make it n sub t, m of the tangent line, just to make it feel special, is going to be delta y over delta x using or between p and x. P, S, go t. Okay, so, ready, set? Step 1, 2, and 3. Step 1, find the distance between the focus and the point on the parabola. Step 2, figure out whether to subtract that from the x or the y to get the other point on the tangent line, and then find the slope as you would between any two random points, although these are not random at all.
Wait, what is that last thing? Is that T beforehand?
Oh, m just means slope. T is of the tangent line, so subscript t. Equals delta y over delta x is the y2 minus the y1, but it's for two different points, so I didn't write it would be like what, y3 minus y1. Just rise over run.
Is that between?
Between, sorry. Did anybody else abbreviate between B to B, T, W, N? Just me. Never mind. Let's do this and then we're done. We have a parabola. I'm going to try to make it as accurate as possible. 2, 1, 2, okay. Not sure that's so accurate. Okay, we have a parabola. Yes, he keeps going. But what are we specifically focused upon? The point 1, 1. Because the point 1, 1, they say, find the slope of the tangent line there. And the slope of the tangent line, we don't know another point unless we use the nifty-difty property of parabolas to say, hey, if we can find the focus, then we know the distance. But to find the focus, struggle. To find the focus, don't we need P? Well, to find P, we'd have to go ahead and take our x squared equals y and think about him in our snazzy form of who's P? Well, I don't know exactly, but I know that 4P must be the coefficient 1.
So that must be 1/4.
Yeah. So 4P equals 1, which implies P equals 1/4. So what does that mean? Where is our focus?
Oh dear.
0, 1/4. You don't like where he is?
No.
See, I was too artistic in my parabola, and so it's a little too high. Okay. But now this is a little too artistic in the sense that that's not hitting where it should, because this should hit at, ooh, wait a minute. What do we know about the focus? Actually, that's probably more accurate the way I had it. The distance, D, between the focus and the point. It's going to be the same distance, okay, I was a little bit off, between the focus and the tangent line. So all I need to do is what we said on the page before. Distance equals the square root of, we have the point 0, 1/4 and the point 1, 1. We're going to have x2 minus x1 squared, y2 minus y1 squared. It's going to end up equaling, 1 squared is 1, 3/4 squared is 9/16. 16, 25/16. Ooh, that's snazzy. So D equals 5/4. So if this D is 5/4, what else is 5/4? This D. Question, kiddos, if we need to go down to the point, are we taking away from the x or from the y to find point 2 or point x? Yeah, so the new point is going to be, take the focus minus the distance, which is going to be cos 0, 1/4 minus 5/4, that's 0, -1. Kiddos, what are we going to do now that we want the slope? Yep. So I'm going to go ahead and highlight our original point, which is 1, 1. I'm going to highlight the new point we found, which is y, or I should say 0.2, and all we got to do is good old slope formula. I'm going to finish this. You guys leave. This is the last page
Hooray.
of 10-2,
Oh,
minus a couple homework help.
so you're
So
gonna
we'll
tell
see
us
how you
to
guys
do it over the weekend?
Yep, do on Monday. What?
And she's gonna check it, but don't tell Ricky.
Oh, are you?
Yeah.
Oh, I thought that the spot check was the day before spring break.
No, she's doing a spot check every day we have to work actually.
Oh, let's see.
So Tyler has to do it. Wait, so that's just the end of the
Yeah. I think as long as it's asking for the slope of the tangent line. Oh, they want the
how much more complicated is it get, obviously?
long story short, we don't have a focus for other functions, so we can't do those snazzy formulas. So we learn something called a derivative that does it for us.
Have a great weekend, just do it.
Bye, guys.
Later. Time with you.